Welcome to this video, again on proof by induction in the A-level further maths series. We're going to be looking at a divisibility proof in this video, and we are going to try and prove that 4 divides 3 to the 2n plus 11 for all n integers that are greater than or equal to 1. And this notation for divides n 3 2n plus 11 means that 3 to the 2n plus 11 over 4 is equal to sum n. Well, in this case in the natural number, that's the notation just means for sum n in the integers. Okay, right, so we're going to take the case where n is equal to 1, just like in the last video, and 3 to the 2 times 1 plus 11 is equal to 9 plus 11, that's equal to 20, and 4 divides 20. Brilliant. So now we're going to assume true for n equals k, and that's for sum n equals k, not for all n equals k, and this is for some k in the natural numbers. Alright, and that, if we assume that's true, we have 3 2k plus 11 is equal to 4m, where m is in z, and that just is from this result, but it's just multiplying that by the 4. Okay, and that means that 3 to the 2k is equal to 4m minus 11, and we write that because when we're considering n equals k plus 1, we will need to use that result, and that form happens to be the more useful version of it. So now we want to consider n equals k plus 1. So we have 3 to the 2 k plus 1 plus 11, and that is equal to 9 times by 3 to the 2k plus 11, and the reason is because of our indices rules. This is 3 to the 2k plus 2, so we can separate those powers by multiplying 3 to the 2 by 3 to the 2k, and 3 to the 2 is 9. Brilliant. So from our assumption, 3 to the 2k, if it's true, if our result's true for some k, is equal to 4m minus 11, and then we still have our plus 11 on the end, and that is not what I'm meant to do. Right, and this is equal to 36m minus 99 plus 11, so that's minus 88. That's equal to 4 multiplied by 9m minus 22, and seeing as this is, we're multiplying by 4 here, well, all of this must be divisible by 4, because dividing by 4 just gives us 9m minus 22, and m's an integer, so that's all of that's an integer. So therefore, therefore true for n equals k implies true for n equals k plus 1, and we have it that it's true for n equals 1, So this result here, we're taking k equal to 1, implies it's true for 2, but the fact that it's true for 2 implies that it's true for 3, the fact that it's true for 4, so on. So if you write some sort of statement at the end explaining that logic, then you will have your marks. That's it for this example. If you've got any questions, please comment them below. If you did enjoy, please like, subscribe and share, and I hope to see you in the next one.